We all know that how weird JavaScript behaves in some cases. There are so many examples, like empty array being equal to negation of a not empty array, which returns a true, not a number not being equal to not a number, which returns false, and my personal favorite 0.1 plus 0.2 equal to not being a 0.3. So these are some crazy examples that you may have seen before, but what I am about to show in this video, this is gonna blow your mind. So we are gonna see about the parseInt. I personally was using a parseInt very heavily when I was a junior developer, and after knowing this, I feel very regretful about the code I wrote. I'm sorry. I feel really sorry for the code that I wrote for the MindThoughts project. I don't know how it's going on. So the parseInt we basically use to convert the floating point number or the decimal numbers to integer. So if I give 0.05 like this, which would give me a 0, which is correct because it is a floating point number, and what I'm interested in is an integer, a whole number. That's what a parseInt is supposed to do, and that's what it is doing. So if I give 1 2 3 4 5 zeros and put a 5, which gives me a correct 0, which is perfectly fine. But what if I just add one more 0 here, 0.00, like this, 3 4 5 6. If I do 6 zeros, then it gives me a 5, which is completely wrong. This is not how a parseInt is supposed to behave. The purpose of the parseInt to give the integer format of a fractional numbers, a floating point number, but after a certain amount of zeros, it's not doing that. What if I add like more zeros? It still keeps on giving me a 5 here. Okay, so we'll try to understand how exactly it works and what thing is causing this problem. So I got the documentation open for the parseInt on the MDM web docs, and the signature of the parseInt is it accepts a string, and then a second argument is a radix. So radix is like a base number on which you want to convert the specified number into any numbering system. Basically, if you provide radix as a 2, it would consider as a binary. If you provide it as 8, then it would consider as a octal. If you give it a 10, then on the basis of the 10, or on the 16 for the hexadecimal. So you can put an integer between 2 to 36 that represent the radix, the base in the mathematical numeral system. So you can have a 2 to 36, any value between that. Okay, let's see. So if I do a parse int of, and if I give a string as a 10, and then my system radix is also 2, which would give me a 2 because 0 1 is actually a 2 in a binary. So 0 1 is the representation of a number 2, which is correct. So what if I give 0 0 1, which is 4? So it's also correct. If I give a 0 0 1, which is 20, so this is working perfectly fine. So with the radix we can put that. Let's change the radix now to something different. So if I give a radix as 8, so if I give 14 to 8, now it returns a 12. So let's try to understand like how the computer processes this. So when a computer detects such a number, what it will do is it will try to pass the numbers from the right side to the left. So it will start from the 4. So what it will do is 4 times 8 raised to 0, because the rightmost is the first position. So 8 raised to 0 will return a 1. 4 into 1 equal to be a 4. Then it will go to a next number, and this time it will be 8 raised to 1 because it's a second position. So 8 raised to 1 will return a 1 again, and 1 into 8 it will return 4, and at the end it will do a summation of that. So 4 plus 8 will return 12. That's why in our case parseInt of the 14 8 returns a 12. So this is how base system work, a simple computer science fundamental, perfectly fine, no problem with it. So now you may be wondering that we can use any number, but wait, if I give a 8 here, and if I have a radix as 8 here and the same number there, then it returns not a number. So the reason behind this, when you are using a base system, there is a rule that your number can be between 0 to base system minus 1. So in my case, I can put anything here between 1 to 7, not 8. If I'm using a 10, then I can put anything from 1 to 9, but not a 10. So it depends on like what base you are using. If you are using n base, then you can give a number which should be less than n minus 1. It should be 0 to n minus 1, not like in something in a negative. It has to be 0 to n minus 1. Okay, that is fine. Now coming back to our actual problem, why does the 0.5 times 0 returns the 0, but 6 times 0 5 returns 6? Why the heck is happening? So now we understand that the parseInt works in this way, that it accepts the string as the first argument and then a radix as a base number in the second argument. So what we are doing here in our example is we are passing it as a directly a number, so it is not a string. So whatever we have passed here, like the 0.4 times 0.5, 5 times 0.5, whatever it is, actually a number, it is not a string. So when you pass a number to a parseInt, what it does, it internally does that conversion. So what I passed here for the 0.005, so JavaScript will convert this to something like this. So 0.005 will actually be like something this, and which will be treated as a string internally. So JavaScript handles this job, like converting a number to a string internally. Because your parseInt accepts a string, it works on the string, it doesn't understand what is a number. So if you pass a number, it has to do that conversion of converting a number to a string. Okay, so this is fine till you have the 4 times 0. If I add a one more 0, then you can see that my string is changed from 0.00, which is the actual representation of a number in a string, to something like this 5e minus 7, which is actually a notation used by JavaScript to represent the higher negative number. So it basically means that I have a 5 into 10 raised to minus 7. It tells that your number has a 7 zeros in front of it, 7 prefix zeros in front of it. So this is a notation used by JavaScript, which is perfectly fine. But the way parseInt now handle this string, parseInt again need to do a next step. First step was to just accept a number, convert it to a string, and in the next step it actually does a conversion from that string to a whole number, to an integer. When it detects this 5e minus 7, what parseInt will do is it will look for a first number in a string and will give that as an output. And that's where the problem is happening. If I give like 0.0005, it would detect that the first number is 0 in a string. 0 is considered as a number, so it would give me a 0. That's why I got a 0 here. But with a one additional 0, it becomes a 5e minus 7. And in this string, parseInt checks for that what is the first number, and it detects that okay, there is a 5 first number, and that's why it printed it. It doesn't care about like what is that there is a e minus 7. It has that information in it. But the way parseInt currently works is just look for the first number, and that's where a root cause of a problem is. So for example, if I give you a parseInt of something like this, if I have a 2 3 2 3 any numbers, then it will give me a parseInt of it. And if I have like e or something, then it would simply ignore that, because it just look for the first number. And after that, even though I have more numbers here, it would not look for that, because it just look for the first number. So here I have a 2e 455. It simply ignore the 455, which were actually a number in the string, but it doesn't care. It just look for the first number in the pattern. Whatever number it has detected, it just treat that as a whole number and show it to you. Okay, good. So we still have the information about like what was the original number, but we still not reached to our goal. Our goal was to convert the fractional number to an integer, and what I got with the number is a 5e7. So your question may be like how we can safely convert a floating point number like this into a whole number, because our parseInt is broken. So what you can do is you can use the math.floor. So if you go for the math.floor and put the same number there, then it would give you a correct representation. So I have 1 2 3 4 5 6 zeros, or whatever zeros I put, it is still giving me a floor of it. So using a something like floor or the ceil to find out a whole number, whole integer from the fraction is the way which is reliable. Is the one way that I know. There could be another way. If you know like there is another safest way or the better way than this, please let me know in the comment. I'll be happy to know that. A number also has this characteristic. So if I give a number and if I just put us, if I do a number of 0.15 or something like this, it's gonna so it is gonna ignore the leading zeros and will give the whole value there, which is fine, I guess, which is not a problem. You can also give fraction and it will give that. It just ignores the zeros that you have. It will not ignore the zeros after the dot. So if I have a 0 after here, which would be preserved, so yeah, you can have the zeros after the decimal, which is perfectly fine. So the conclusion is using the parseInt to convert a fractional numbers to a integer number, it is not a safest. It can cause a serious bugs. I have used it in the past and I really feel stupid about it. So for God's sake, don't use a parseInt from now. To avoid this problem, you can write your own custom safe parseInt function, which would cover all the cases type of a given input. So we are going to check if it is a number or if it is a string, then it is fine, we are going to process. But if it is not a number or string, something which is not number or string, maybe not a number, then we are simply not going to proceed in that case. So it works on the same principle that I talk. We'll use a number object, and additionally when we'll get something like 5e or something or notation where we have too many zeros, we are going to use a math truncate. So to quickly show you what will happen in this case is I will have a math.truncate applied on my value, which will be 5e minus 7, and it will give me a 0, because if the number is not integer it will truncate towards the 0 and it will give the 0. So with the combination of a truncate and identifying the type of a given input, we can avoid this problem. So let's see if this works. If I run this, so I got 0 for the 5 times 0, and for the 6 times 0 I also got a 0. So this is how you can fix it, but you have to write your own safe parseInt function for that. If you are aware of any other alternative or any solution better than this, more cleaner than this, let me know in the comment. And don't ever use a parseInt blindly without knowing it.